Have you experienced any inconsistencies in test failures? Have you ever run tests and they run perfectly 1 minute and then the next run fails? Or you get sporadic failures on different runs between tests? If any of that rings true, then please keep listening. In this video, I'm going to explain 5 reasons for test automations failing. And by test automations, I'm talking about everything from unit testing through integration testing to functional testing, be that automated through the UI or automated at an API level. Hi, I'm Andy. Welcome to Narcolepsy Pumpkin. If you haven't been here before, a warm welcome to you. If you have been here before, then I really appreciate your support. These 5 reasons I'm going to go through are in no particular order. Deployment, and that's where a deployment is going on while tests are running. That can cause tests to fail, particularly any integration tests or anything that's testing functionally through a UI or through an API layer. So where testing is occurring with the actual environment in a kind of real scenario kind of way, having deployments running could be causing an issue. Also things like systems patching, network outages.
Is it good that it's doing that?
Now that poses one of 2 things, either an opportunity to improve the availability of your application, make it so that it will actually survive those deployments and patching activities and keep the system up and alive in a way that allows tests to continue to run and pass. The other thing you can do to try and mitigate this is to have more coordination between test runs and other activities like deployments and patching. Quite a simple solution. Race conditions within tests, and this is where a test might fire off 2 actions that are happening in an asynchronous way. One side of that race condition actually happens faster, meaning the results actually arrive in a different order to expected.
Who's there?
Knock.
This kind of failure tends to look quite random because it can be really time dependent. So when the system's under load, you could have tests failing, or vice versa. The tests only pass when the system is under load. These particular types of failures are the kind that are really dangerous in that they can often lead to complacency in failing tests. The result of the test becomes so meaningless it gets ignored. If that's allowed to institutionalize so that people just expect that as the norm, that really renders the whole test suite and the test results completely useless. Coupling between tests or assumptions made in tests prior to them running. So if any external factors are changing data that tests depend on, that will ultimately result in a test failing until that data is corrected to a known state, or the test is changed so its expectation of its starting point is different. Now that could represent 2 things. Either there's a level of maintenance for the test that's not happening, and that could be because of genuine changes in config and behavior causing the test to fail that hasn't been identified and corrected prior to the test suite running.
Oh, let's try a sentence.
It could also mean that there's quite a dangerous coupling or expectation in the tests. So having tests that will only run in a sequential order will often work on a developer's machine, particularly with unit tests. However, when these get into a pipeline or automated state, they're often run in parallel and are not run in any particular order. This is often by intent to make sure those tests are isolated and valuable in their own right. Any test that depends on another test having run first is not good practice.
A new wind is blowing.
Differences in environment causing tests to fail, and this is because there's some assumptions or differences in the starting point or state of the environment. Be that there are different components, different connectivity, different connection strings, or there are some assumption about how the system functions that is incorrect. This could identify that you've got a drift in versioning between environments, or there is in fact an issue with the way code is deployed and running in different environments. Test failures can also be caused by seemingly innocuous changes to the system. That could be something quite simplistic having changed in a UI, or something quite simplistic changed in terms of data or implementation. There's too much dependency on the how something has been done as opposed to what it does. This can often happen in functional testing, where you're testing through the UI, where the tests themselves are really coupled to how the UI actually looks. They're trying to assert too much about the look and feel. Look and feel of a web application or a system should probably be pushed to the bit that's done by human beings, i.e. looking, eyes on screens, telling you whether that looks right or not. Trying to automate that level of testing is very difficult and makes a lot of the system quite fragile. When small things are changed, that can have swathes of tests failing, which in turn puts an awful lot of maintenance effort into keeping those tests passing. And if you're having to maintain and change tests every time you make a very small change to the system, then it might be that you're testing too much of that implementation detail, and it needs to be scaled back to just the behavior. Okay, there is a behavioral sweet spot when it comes to the testing surface area. If you consider that to be the intersection between tests that are looking at detail and tests that are looking at function. And we're looking to test this piece in the middle. This bit in the middle is our set of valuable tests. And the reason for that is that the more detail we test, the deeper we go to that side, the more fragile these tests are. So small changes end up breaking huge swathes of functionality. If we weigh in really deep to the functional testing, so you've got lots and lots of tests testing every granular function from every different way, there is a level of diminishing returns there. And that's the amount of new valuable behavior you're asserting by having those tests. There's a point where there's enough triangulation, so you've tested it from enough angles for it to be valuable and safe in the knowledge that you've covered everything that you need to. You need to stop at that point, because if you continue down that journey, yes, you've got more tests, potentially you've got more safety, but the level of return you're getting from that effort is lower and lower. And you've got to think from the point of maintaining these tests. Having more tests is more to maintain. So it's just a matter of pragmatism, really. In unit tests as well, some elements of refactoring has resulted in tests technically being coupled by things like mocks. Because of that coupling through the test doubles means that any changes to behavior for a particular scenario could have an impact on one of those mocks. The mock is changed for that scenario, but unbeknown to that person, it's been used elsewhere. It is a good idea in this case to only use mocks that are specific to a particular scenario.
Your unit tests are weak, old friend.
So what I'm saying is that you can write test A, and then that can depend on a mock. And that mock sets up everything that test A needs, and that's fine. We then write test B. This is a slightly different but incredibly similar test case, and it is capable of using the same mock. So we apply dry. We don't want to repeat ourselves, so we reuse the mock. And that's fine. Everything's good. Until test case A has to change what this mock actually sets up for that test. This inadvertently makes test B fail. And that is not a good thing. So what we actually need to do is think about not having this dependency and having a duplicate mock. with just the state for test B. This effectively isolates test A and test B in terms of their initial setup state. Any changes required for B are reflected in its dependent mock. Anything for A are reflected in its dependent mock. And this, though appears to violate dry, it's actually single responsibility. This mock is responsible for this test. This mock is responsible for this test. They are going to change for different reasons because this test isn't the same as this test. They might be similar, but they're not the same. So it's usually a good idea to have mocks that kind of double things up. When it comes to fakes, however, if they're a true fake, i.e. they replicate the behaviour of the real thing exactly, then they can be shared without any problem at all. We've covered 5 what I think are pretty common reasons for test automations to fail. If you've had any other experience or would like to share anything that you found that's causing test automation to fail, then please put that in the comments below. And if you've enjoyed this video, then please let YouTube know by clicking like. And if you want to hear more from me, then please click on subscribe, click on the bell to get notifications when I post new videos. And again, thanks for your support and thanks for watching. See you next time.